Welcome to EDU World Space.
So in this video, we're going to work through question 62 from chapter 20, which asks us to complete and balance each of the following reactions. And in A, we're given the reaction between sulfur dioxide gas and oxygen gas. So sulfur dioxide, that's SO2, and oxygen, that's O2. So we have SO2 plus O2. And what sulfur actually likes to do in the situation is to form sulfur trioxide. So we have SO3. So how are we going to balance this? Well, we have one sulfur atom on each side of the equation, but we have different numbers of oxygen atoms. So we have 3 oxygen atoms on the right and 4 oxygen atoms on the left. How can we balance an odd number of oxygen atoms and an even number of oxygen atoms? Well, we need both of them to be even numbers, so let's put a coefficient of 2 in front of SO3. So now we have 2 sulfur atoms on the right and 1 sulfur atom on the left. So we need to also put a coefficient of 2 in front of SO2. So that gives us 4 plus 2, that's 6 oxygen atoms on the reactant side and 6 oxygen atoms on the product side. So this is a balanced equation. So the balanced reaction between sulfur dioxide gas and oxygen gas is 2SO2 plus O2 yields 2SO3. In B, we're given the reaction between sulfur trioxide gas and water. So we have SO3 plus H2O. And what are we going to form from this? Well, sulfur trioxide reacts with water to form sulfuric acid, which is H2SO4. So is this balanced? We have 2 hydrogen atoms on both sides of the equation, 1 sulfur atom on both sides of the equation. 3 plus 1 gives us 4 oxygen atoms in our reactants and 4 oxygen atoms in our product. So this is already balanced. So the balanced equation is SO3 plus H2O yields H2SO4. In C, we're asked about the reaction between concentrated sulfuric acid and sucrose. So this one's actually pretty interesting. So sulfuric acid has this affinity for water that allows it to form hydrates of water. So we use it to dehydrate other things, other molecules. So essentially what we're going to do is our H2SO4 is going to react with our sucrose, which has the formula C12H22O11, until all we have left is carbon. So we're going to form carbon, and then what happens to all of the hydrogen and oxygen atoms that were in sucrose? Well, they're forming a hydrate with our H2SO4. So actually, let me put this on the next line. Plus H2SO4. And the way we write a hydrate is you write dot and then H2O, or if it's a dihydrate or a trihydrate, or it has more than one water molecule, you would put dot 2H2O or dot 3H2O, etc. But in this case, we have just one H2O hydrating our H2SO4. So how are we going to balance this? Well, to start off with, we know that we have 12 carbon atoms on the left, and so we need 12 carbon atoms on the right. So we put a 12 in front of our carbon. And then we need to know how many water molecules we can extract from C12H22O11. So we have 22 hydrogen atoms and 11 oxygen atoms. And we know the formula for water is H2O, so H2O times 11 would give us H22O11. So it's going to be 11. So we have 11 water molecules. And if we have 11 H2SO4 hydrates, then we started out with 11 H2SO4. So the balanced equation is 11 H2SO4 plus C12H22O11 yields 12C plus 11 H2SO4 H2O.